Burning night, when Kilauea turned Hawaii into daytime in a 1,500-foot lava ejection. The supposedly silent night sky suddenly transformed into a blazing apocalypse. Above the dark landscape of Hawaii, a fiery red light burst from the earth, sweeping away the darkness like a forced dawn. Within seconds, a giant lava jet shot 1,500 feet into the air, forming a curtain of fire that pulsed, rumbled, and reflected its heat into the low clouds. Night was no more replaced by a dazzling and terrifying artificial day. At the center of this event stood Kilauea, one of the world's most active volcanoes. But this time, what was happening went beyond the usual volcanic routine. Scientists witnessed the extreme phenomenon of highly gas-rich basaltic magma rising under tremendous pressure from deep within the Earth's mantle. Trapped gases such as carbon dioxide and sulfur dioxide propelled the magma upward with explosive force, creating a lava ejection that was not just a stream, but a high-energy vertical jet that pierced the night atmosphere. Below the surface, the unfolding process was equally dramatic. Eruption channels, or lava conduits, form with astonishing speed. Small cracks in the Earth's crust suddenly widen, creating a pathway for magma to surge to the surface. Within minutes, internal pressure carves a new path, accelerating the flow and increasing the volume of the eruption. This isn't just an eruption, it's a real-time re-engineering of the landscape by unstoppable geological forces. The speed of the lava flow erupting from its source is also astonishing. The river of fire moves at a rate capable of engulfing vegetation, roads, and even man-made structures in an instant. As the lava flows down the slope, it burns, melts, and reshapes the surrounding topography. Previously stable ground is transformed into a fluid, moving terrain, creating new land while destroying old. At the monitoring center, scientists from the USGS and the Hawaiian Volcano Observatory are glued to their screens. The real-time data shows an unusual spike. Tilt meters are recording a sudden change in the slope of the ground, indicating increasing magma pressure. Interferometric synthetic aperture radar (INSAR) technology revealed large-scale surface deformation, while gas spectrum analysis revealed a spike in sulfur dioxide emissions to dangerous levels. The reaction in the control room shifted from scientific calm to full alarm. Alarms sounded, graphs spiked sharply, and emergency communications were immediately initiated. Decisions had to be made in a matter of minutes. The surrounding area was sealed off, evacuation routes were activated, and air quality warnings were issued to protect residents from toxic gas exposure. It was a race against time between science and the forces of nature. On the ground, residents witnessed a phenomenon that was both mesmerizing and terrifying. The flaming sky cast sharp shadows on the ground, while a rumbling sound like a giant heartbeat shook the air. But beneath the beauty lurked a serious threat. Volcanic smog, or VOG, blanketed the air, a mixture of toxic gases and fine particles that can damage the respiratory system. Among the flying ash, thin shards of volcanic glass known as Pele's hair floated, sharp and dangerous if inhaled or touched the skin. The danger increased as the lava approached the shoreline. When this hot material met seawater, an explosive reaction occurred, a steam explosion that could hurl rocks and produce toxic gases like hydrochloric acid. This interaction created a new danger zone, invisible to the naked eye, yet deadly to anyone who got too close. Infrastructure was also under immediate threat. Major roads were cut off by lava flows, power grids were disrupted, and water systems were at risk of contamination. Within hours, a previously vibrant region had become a crisis zone. Every second brought change. Every minute brought new risks. But amidst the chaos, there were important lessons. Data from the USGS and the Hawaiian Volcano Observatory showed early signs that are now key to mitigation: increased gas emissions, ground deformation, and increased seismic activity. Understanding these signals could save lives, allowing time for evacuations before the disaster reached its peak. And as the eruption subsided, the light slowly faded, returning the lost night. But the scars remained: the changed land, the still toxic air, and the memory of a time when the Earth displayed its rawest power. In Hawaii, night had turned to day, and the world was reminded that beneath our feet, a gigantic force always waits to awaken again.